A system of equations is a set of two or more linear equations that are given together. The answer to a system is the point where both of the linear equations intersect. There are three main solving methods: equal values method, substitution, and elimination. Equal values method is a method for solving a system of equations where we can take two expressions that equal y and set them equal to each other. We can use it to solve the system below. We can use a real-life example to see how this works. Visualize that a dime is equal 10 pennies, and a dime is also equal 2 nickels. So in this case, that must mean that 2 nickels must also equal 10 pennies. This is similar to a system since the first equation equals y and the second equation equals y, so that means these two parts of the equation must also equal each other. After this, we can solve the new equation normally, like a one equation, since it is now one equation with one variable. We add 3x, subtract 5, and divide by 7. Note that what you do to one side must also be done to the other. In the end, we get that x equals negative 2. To solve for y, we would take one of the original equations. I chose y equals 4x plus 5 because I thought it would be easier to work with without any negatives. Instead of using x, we would use negative 2. Then solve the equation normally. In the end, we get x equals negative 2 and y equals negative 3. We would put this in an ordered pair, like so. We can check our work in a few different ways. One of them is by making a graph. After making the graph and drawing both lines, you can see that the point of intersection is indeed negative 2 and negative 3. We can also check our work algebraically. By plugging in negative 3 for y and negative 2 for x, we can see that both equations do in fact work. The second method is substitution. It is a way to change two equations with two variables into one equation with one variable. It is convenient to use when one equation is already solved for a variable. As you can see in this system, y is defined as 2x minus 4. This means that instead of using y, you can use 2x minus 4 to replace it. We solve the equation normally, and we get x equals negative 2. Again, after that, we use one of the original equations, plug in negative 2 for x, and solve for y. Our final answer would be negative 2 equals x, and negative 8 equals y. Another method of checking our work is with the table. We could plot out each point, and afterwards see that the 2 points that the equation had in common are negative 2 and negative 8, which would be our answer. And again, checking our work on a graph to see that the answer is correct once more. All 3 times we got the same answer, so we most know that it's correct. The third and final way is elimination. This method involves adding both sides of two equations to eliminate a variable. Equations can be combined this way because balance is maintained when equal amounts are added to both sides of an equation. Our goal is to remove one of the variables and turn two equations with two variables into one equation with one variable. To do this, we would match negative 4y and positive 4y together, so when they are combined, they cancel out. To do this, we must multiply the bottom equation by 2. Then we can combine both of the equations to get 18x equals 36, then solve it normally. We would get x equals 2. Again, we would solve for y by plugging in one of the original equations. Instead of using x, we would use 2, and see that y equals negative 0.5. Our final answer would be x equals 2 and y equals negative 0.5. We check our work again with a table and a graph and see that it matches all 3 times. There are 2 special occasions that can happen when you're solving a system. They are no solution and all real numbers. Let's start off by looking at no solution with this system below. After solving it, we would see that our final equation is negative 16 equals negative 32. This is impossible. which means that no matter what x and y is, they will never intersect. After graphing them both, we can see that the lines are parallel. A system with no solution happens when both of the equations have the same slope but different intercepts. Next, all real number happens when the two equations are the same thing. Look at the system below. After solving the system, we can see that we get 6x equals 6x. This means that as long as x and y is a real number, then no matter what we put, the two lines would intersect at each and every point. Our final answer would be all real numbers.